over the course of its long history and will continue to change without any help from us.
Climate always changes, you know. Who denies climate change? It's always changing.
But if CO2 doesn't drive climate change, what does? In Earth's atmosphere, there are powerful forces at work, and perhaps the most powerful of all are clouds.
CO2 is quite unimportant in controlling the Earth's climate. What is important is clouds. Clouds don't absorb any energy at all. They simply reflect all of the sunlight back out into space. Big, bright, white clouds. If you look at the Earth, you see lots and lots of them, and they vary dramatically from one day to the next. That is hundreds of times more powerful than the trivial effects of CO2.
But what controls the number and density of clouds on Earth? Professor Henrik Svensmark from the Danish National Space Institute is in Jerusalem with the astrophysicist Nir Shaviv. Together they've been exploring cloud variation and its effect on climate. And strangely, they've found a link between clouds and exploding supernovae far off in our galaxy.
When you have big stars, they don't live very long. Relatively only maybe a few million years, up to 40 million years. But they end their life in a huge explosion, which we call the supernova.
An exploding supernova sends out vast quantities of debris, tiny charged subatomic particles known as cosmic rays, traveling almost at the speed of light. And as they hit Earth, they develop into seeds which attract water vapor and form clouds. Professor Shaviv noticed that the amount of cloud cover on Earth is related to our journey round the Milky Way. As our solar system orbits the galaxy over millions of years, it passes through the galaxy's spiral arms, dense clusters of stars. As it does, we are exposed to more or less cloud-forming cosmic rays, and this corresponds to historic temperature changes on Earth.
The really mind-boggling thing is that using geology, you can reconstruct the climate on Earth over the past billion years, and you can reconstruct our galactic journey, and both tell the same story.
But what about temperature change on shorter timescales? The Sun, our source of heat and light, a seething mass of gigantic magnetic storms, which vary in strength and number over time, and which affect Earth directly and indirectly. When it is very active, the Sun sends giant gusts of solar wind through the solar system. The solar wind warms us indirectly by acting as a barrier, limiting the number of cloud-forming cosmic rays reaching Earth.
So from the Sun, we have the solar wind. It carries the Sun's magnetic field out to a large distance, and it works like a shield against cosmic rays.
That when the Sun is more active, you have a stronger solar wind, you have less cosmic rays reaching the inner solar system and reaching the atmosphere, and the clouds which are then formed are less white. They reflect less of the sunlight, which means that it's going to be warmer here on Earth.
Here is a proxy reconstruction of ocean temperatures over thousands of years. And here is one of solar activity over the same period. What is causing the ocean temperature to change is clearly variations in solar activity.
Because IPCC is determined to go on a narrative that only CO2 can drive the climate system, they turn off the sun essentially, right? Because the sun is just a background thing for them, that it doesn't do anything.
Astrophysicist Uili Sun decided to look again at the rural temperature record for the past 150 years. Then he looked at a record of changes in solar activity over the same period. To Dr. Sun, it was obvious that it was the sun, not CO2, that was driving temperature.
As of 2023, IPCC says is that the sun have absolutely zero chance to explain the changes of the climate system on a broad scale, let's say global warming or northern hemisphere. We say no. We can easily demonstrate, the sun can explain all of it. There's 0 for the CO2, 100% for the sun. How's that?